Kia ora Ben, Tausif and Snehal. I'm making this video for you to go through the practice task about cows grazing in the paddocks. So if anyone else is watching, this is a practice task for level 2 trig, and it's an old one from, I think, from the NZQA exemplars, but it's not up there anymore. So it doesn't have any circular measure in it. It's all about a quadrilateral that you have to chop up into triangular paddocks. There's a diagram coming on the next page and also some formulae. So the first thing to do when you're doing one of these NCEA tasks is to read the question through really carefully and look at the diagram. So a farmer has got a huge paddock that he wants to fence off to create 4 smaller paddocks in order to graze his cows on a 4-weekly rotation. So that means that all of the cows are going to be in one of these paddocks for 1 week out of 4. The bare minimum the herd requires is 25,000 metres squared of pasture. So that clearly is going to be important in our problem. He has made a request to find out if it would be viable to run a fence along one of the diagonals, as shown in the diagram, and then connect the other corners to the middle of this fence, thereby creating 4 triangular paddocks. Right, note that by connecting to the middle of the diagonal, it will split the larger triangle into 2 equal halves. So let's now look at the diagram. So that's the formula. That's the diagram we're given there. Okay, so you can see that we've got one angle here, and we've been given all 4 lengths, and it's suggested that he chops the paddock up along there. So straight away, you can see that we're going to be working with 2 triangles, and my first step is going to be to find all of the sides and the angles in there, and we'll go from there. Okay, but back to the problem. If the paddocks are not 25,000 metres squared, then suggest an alternative that would enable him to have 4 paddocks of the required size. So you can probably guess that the paddocks actually are not going to work out to be right doing it this way, and we're going to have to get a little bit creative. So now I'm going to look at the formulae. I want to talk about these a wee bit. In this problem, there is no circular measure, so we know that in this one, well, we pretty much know, unless we're going to get really weird, we're not going to have any arc length, sector, or segment calculations. We're going to be using all of these over and over again, and when I do this video, I'm going to be going really fast through those calculations. So before you get to the internal, you have to make sure that you know exactly when we can use the sine rule and then how we use the cosine rule. So basically, if you've got a triangle and you've got an angle and you've got the opposite side, then you can use the sine rule effectively. You can either use it in this form where you've got the length in the numerator, or you can use it in the reciprocal form like this. Okay, so I'll be doing both of those, I think, in this video. And then these two are different rearrangements of the cosine rule, and we have to find the area of triangles, and we're going to have to do that over and over. So if we want to get the area of that whole quadrilateral, the only way we've got to do that is to break that into triangles. So what I want you to do now is just to pause the video and write down the steps that you're going to follow, and then take this problem as far as you can. So give yourself maybe 10 minutes and go hard out to get as much done as possible. This video is probably going to have 2 parts because I'm already up to 3 minutes and I haven't even done any maths calculations yet. Okay, so here are my steps that I'm going to do. First, I'm going to label, draw, and find the obvious missing angles and lengths. Then I'm going to find the area of the 2 big triangles and the total area. And I'm going to ask at that point whether splitting those up into 4 triangles will work or not, right? So I'm going to get this area here. Where are we? Pens turn off there. So I'm going to get that area, I'm going to get that area, and I'm going to add them up. And if I want to have 2 paddocks here, I'm drawing that wrong. Let's draw that a little bit better. So if they're suggesting that we split it like this, as a way to get these 4 paddocks, that might work. In order for that to work, I've got to have this area here and this area here both be bigger than 50,000 metres squared, right? Because if each paddock is going to have 25,000, that's got to be the case. So yeah, first things that I'm going to do, again, label, draw, and find those angles and lengths. And we're going to do that with full working, but we're going to do that very, very quickly because that's not where the creative part of this task is. Okay, so here's my first triangle. I'm going to do some labeling. So we've got vertices A, B, and C, and then D is the one down here. So area down here, this is A, B, C, D. We can straight away get the area of ACD. So triangle ACD area is equal to half AB sine C. So that's half of the two sides and the included angle, so half of 430 times 540 times sine of 70 degrees, straight away giving me an area of 109,098.3 meters squared. The next thing that I want to know is the length of this diagonal here, right? And I'm going to have to use the cosine rule for that because I don't have an angle in the opposite side. So length AC comes from the cosine rule. So length AC squared is this. And when I work that through, what do we get? Well, we get 540 squared plus 470 squared minus 2 times 540 times 470 times cos of 70 degrees. Working that through my calculator gives me AC squared is equal to some number that I completely forgot to write down. And square rooting that, I get 563.62 meters. So that's AC. Now the next thing that I'm going to work out is I'm going to go back to this top triangle. Right now we now know that this side here is 563.62 meters. That means that I can work out this angle, and then I'm going to get these two angles as well. I'll come back then to the bottom triangle and get the angles on that one there. Right, so to work out angle, what have I done? I've done angle ABC. Oh, so actually I did this using the cosine rule. Yeah, of course I did it using the cosine rule because I don't have any angles on here yet. Right, so if you have no angles, you can't use the sine rule. So here, make this theta. Cos of theta is going to equal 270 squared plus 370 squared minus 563.62 squared divided by 2 times 270 times 370. So that gives me a negative 0.53988 for cos of theta. Now, if you think about your cosine graphs, guys, you know that that means that we've got an obtuse angle and we're going to be somewhere around here, right? So that makes sense from looking at that diagram. So even though the diagram is not to scale, you can get a bit of an idea for what's going on. You have to be a bit careful doing that though. So theta is equal to 122.68 degrees. I'm going to keep it to that for now. You don't need to write out lots and lots of decimal places. So now that we've got that angle, we've got this ticked off, and we've got this and this. So we can get the area of this triangle as well. Right, so down here, the area of triangle ABC is equal to 1/2 times 270 times 370 times sine of 122.68 degrees. And that gives me 42,042.88 meters squared, which is less than 50,000 meters squared. So can't split triangle ABC into two to get 2 paddocks over 25,000 meters squared. So we need some kind of communication like that. If you're aiming to get excellence in this task, you need to do really good working, but also some good explaining of why you're saying what you're saying, right? So we know that our strategy is not going to be as simple as whacking a line in here and here. That's not going to work. These ones are going to be too small, okay? But what might work instead, if we don't divide through here, we've obviously got enough room to do the four things though, right? Because we can see that the area of ACD is pretty massive, right? So that's well over what we need to do, actually all 4 paddocks. That number is not looking right to me anymore. Oh no, yes it is. Right, so you can see that this is huge, right? We can do 2 paddocks of nearly 55,000 square meters in here, but this is the bit that's too little. So what we should already be thinking about doing is, instead of dividing it from B to D, if we do the split down here like this, things should work out better. Okay, so we're going to now rearrange how we split the triangle up. But before we start doing that, it would be well worth it to just slow down a bit and look at the angles that we've got on here so far. So we've got this one, and we've got this one. This one was the one that was 122, but now working with each of the separate triangles, we're going to get this angle, and then this angle, and this angle. And that means that once we split the triangle differently, we can combine to get that angle and to get that angle and be working with that triangle there. Okay, so they are your next steps, right? So we're going to carefully now, but not too carefully, not like an Olympiad kind of carefully. We're going to draw out those 2 triangles. So draw out for yourself the 2 triangles that are there already and get those angles. Now I'm going to do it really, oh no, I am going to use a ruler because it looks so bad if you do it without a ruler. So let's just use a ruler. We're going to do ACD with roughly correct. You know, not crazy off scale. Actually, this is kind of crazy off scale, but what's really important when you're doing a long problem like this is not to get sloppy on your labeling, because we're going to have a lot of angles, right? So we know that angle ADC is that 70-degree one from the original diagram, and we've got those lengths there. So draw those on, and then I just labeled those 2 angles theta and phi. Right, so we can now find those angles, and we can do that using the sine rule, because we also know that this length here is 563.62 meters. So I'm going to do the sine rule to get angle CAD. So CAD is theta. So sine theta over 430 is equal to sine of 70 over 563.62. And when you work that through, you should get that theta works out to be 45.8 degrees. Okay, and then we can get phi, which is angle ACD, using angles in a triangle, which is just going to be this. Let's see, is that right? Yeah, we know this one's 70 here, that's right, minus 70, and that gives us 64.2 degrees. So I'm going to pause this video, and I will do the rest of this later on tonight, but hopefully that gives you enough to get going on. You're not even watching this, it's Saturday, so by the time you watch this, hopefully the whole problem will be done.